Hi everyone, this is the second part of the lipoprotein. We have already discussed chylomicron and very low density lipoprotein in the previous video. Now you will see about the low density lipoprotein. Low density lipoprotein mostly is derived from the very low density lipoprotein. The half-life period of this low density lipoprotein is 2 days. The ApoB100 is the major apoprotein here. The function: the LDL transports cholesterol from liver to the peripheral tissue. This low density lipoprotein function is mainly it transfers cholesterol from liver to the peripheral tissue. It gets the cholesterol from the liver and transfers it to the peripheral tissue. This is the function of low density lipoprotein. Now we will see the metabolism of the low density lipoprotein. The metabolism of the low density lipoprotein is the LDL receptor are present on the all cells almost in liver. Mostly this LDL receptor which is present almost in all parts of the liver, and the LDL receptor are located in the special region called calthrin coated pits. This is the region where the LDL receptor are mostly present, which is calthrin coated pits. The LDL is taken up by the peripheral tissue by receptor with the help of ApoB100. This LDL is taken up by the peripheral tissue by the receptor with the help of Apo. This ApoB100, which is the apoprotein of the LDL, takes up the LDL from the peripheral tissue. And it forms a LDL receptor complex and is internalized. The lysosome fuses with the LDL receptor. After there is a LDL receptor complex formation, this lysosome fuses with the LDL receptor complex and hydrolyze the LDL complex to amino acid and cholesterol. By the action of hydrolase, this lysosome hydrolyzes the LDL receptor into amino acid as well as cholesterol. The 70% of the cholesterol is degraded in the liver. The free receptor return to the cell surface. The free receptor returns to the cell surface and the 70% of the cholesterol is degraded in the liver. In peripheral tissue, the cholesterol can be used for the synthesis of steroid hormone, incorporated into the cell membrane, esterified to MAFA, mononucleotide rated fatty acid by ACAT. These are the peripheral tissue cholesterol can be used for the synthesis of steroid hormone. These are the uses of the peripheral cholesterol, which is used for steroid hormone synthesis as well as incorporated into cell membrane, esterified to MAFA, which is mononucleotide rated fatty acid. The clinical application of the LDL is increased level of LDL is increased cholesterol taken up by the macrophage. And it is not regulated pathway. The LDL is infiltrated through the atrial wall and taken up by the macrophage. And this causes atherosclerosis leading to the myocardial infarction. The increased level of LDL is increased cholesterol takes uptake, and it is not regulated by the pathway which is LDL infiltrated through the atrial wall and takes up by the macrophage, and this is because of the atherosclerosis leading to the myocardial infarction. So the LDL is called as bad cholesterol, and the LDL is normal level is 80 to 150 milligram. When there is increased level of LDL, the cholesterol is taken up by the macrophages, and it is regulated as LDL infiltrated to the atrial wall. This LDL is infiltrated to the atrial wall and it is taken up by the macrophages, and this causes atherosclerosis as well as myocardial infarction. Now we will see about the metabolism of the HDL, which is otherwise known as good cholesterol. The function is the HDL transport. We have seen that the LDL transports the cholesterol from the liver to the peripheral tissue, but here it transfers from the cholesterol to the peripheral tissue to the liver with the help of the protein which is ApoA, ApoC1, ApoE, and HDL, which is high density lipoprotein, serves a plasma reservoir of the ApoC and ApoE. The metabolism of this are synthesis in the intestine. The free cholesterol is derived from the peripheral tissue are taken up by the HDL. The free cholesterol which is synthesized from the peripheral tissue is taken up by the HDL and is transported to the liver. the cholesterol acyl transferase, which is LCAT. The LCAT transfers fatty acids attached to the second carbon of lecithin. The second carbon of the lecithin, there is a cholesterol is attached to the third OH group of the cholesterol. These forms cholesterol esters and it moves to the HDL. The reaction continues till the HDL becomes spherical and it is known as HDL3. This mature HDL is taken up by the hepatic lipase hydrolase and HDL phospholipid, triglyceride, cholesterol esters are released into the liver. The cholesterol is used for the synthesis of bile acid and excreted through the bile. The HDL normal level is 30 to 60 mg/%. Thank you. If you want more videos, please do like, share and subscribe my YouTube channel. If you have any doubt in it, please do comment it. If you want any other topic to suggest, please do suggest in the comment box. Thank you.